Okay, so today we're going to start talking about exponential equations and logarithmic equations. So remember that every time we do something, we learn how to do a new skill. Like we learned how to do logarithms, we're dealing with exponents, and then we always take the last couple of sections of a chapter and we apply those to equations. Now, I like log equations and I like exponential equations mainly because they look like something crazy. We've never seen them before. We've never done them before. But what you're going to find out is with 3 simple steps, it's going to go right into basic algebra 1, even a pre-algebra type thing. So I want you to pay attention while we do this. Again, stop the video, look at the steps, think them through, understand them, watch the video twice. I'm trying to make these short enough where you're not going to fall asleep in them. So let's get started. Remember, as we go through this, you will always use logarithms to solve exponential equations, and you will use exponents to solve logarithms. Remember back at the end of chapter 6, the beginning of this chapter, we talked about inverses, and we talked about how logarithms and exponents are inverses. So this is what we're going to be utilizing to be able to solve some equations. Our key concept is exponential equations, and how do we solve? Given an exponential equation, the first thing that we're going to do is take the log of both sides. That's all I did. 5 to the 2x is equal to 16. The log base 5 to the 2x is equal to the log of 16. Now I'm going to use my power property, and I'm going to bring the 2x down. I'm going to divide by the 2 log 5. Remember that 2 is a constant and the log of 5 is a constant. They just represent numbers. So once I get it into x is equal to the log of 16 divided by 2 log 5, that's an adventure on your calculator. Again, be careful with parentheses. And your answer is 0.421. Boom. That's it. 3 steps. Notice that after step 2, it becomes basic algebra. 7 minus 5 to the 2x minus 1 is equal to 4. We're going to move the 7 over, just like we would do. We want to isolate the exponential term. Then we take the log of both sides. Our exponent becomes our coefficient. We just simply divide by the log of 5 and solve for x, keeping in mind that the log of 3 divided by the log of 5 is just a number. And x is equal to 0.84. Here's another one. 4 plus 3 to the x plus 2 is equal to 4. Now let me ask you something. Is there a number that I could raise 10 to get 0? There is not. So this particular log does not exist. So there is no solution. There is no number that I can raise 10 to get 0. I could raise 10 to a number and get pretty stinking close to 0, right? 10 to the 1 over a million would get me close to 0, but it's not 0, so it doesn't count. So now let's look at solving logarithmic equations. Remember we said that we used logs for exponential equations. Now we're going to use exponents to solve logarithmic equations. In the first example of log 2x minus 2 is equal to 4, I'm going to first rewrite it as an exponent. So 10 to the 4th is equal to 2x minus 2. 10 to the 4th is 10,000. That I can do. So now I have 10,000 is equal to 2x minus 2. 9,998 over 2 is equal to x. So I get x is equal to 4,995. Notice after that very first step here, right? Once you rewrote it as an exponent, look how simple it becomes. It's quite an elegant way to manipulate an equation. First thing we do here is we write it as a single log, then we rewrite it as an exponent, and we solve. Yes, there are a lot of decimals when we're doing logarithms, okay? So you need to get used to that. The first thing we did is we rewrote it as a single log, then we wrote it in exponential form, and then we solved for x. Easy peasy. Again, we rewrite it as a single log. We're going to simplify it this time. Then we're going to write it as an exponent. 10 squared is equal to 3x squared. And then you just simplify it. You solve it. Condense it into a single log. Write it as an exponent. Simplify it. You notice that you have x squared, so this is a quadratic equation. You know you can factor it. How do we solve quadratic equations? Factoring, completing the square, or the quadratic formula. In any case, your answer is x is equal to 8 or 1. See how easy that is? One more. Now, in this particular case, I want you to look at something. We're going to rewrite this, the left and the right-hand side, with the same base. And because I could do that, if I have 5 to the 1 minus 2x is equal to 5 to the third, if my bases are the same, then my exponents have to equal for this to be a true statement. So now I have 1 minus 2x is equal to 3, negative 2x is equal to 2, x is equal to negative 1. Okay? So it's just amazing. I just think that these just take something that looks really, really difficult, and just by using a few little tricks, it makes it doable. So I was going to do this on natural logs, and then I decided not to. Okay? Natural logs, this is just a little preview. Natural logs will be your next section. So now you're going to work on your Math Excel, and you're going to work on your daily check. At the end of this, well, actually, you just had a quiz on 7.3 and 7.4. And then you have only one more section to do.